Right. You can take it away, Tom.
All right. Thanks for the introduction, Anne. Thanks everybody for their time and attention for this. My day job is I'm a teaching faculty here at the UW-Madison in the Department of Plant Science and Agroecosystems. But that's 9 months out of the year, and so the other 9 months out of the year, I farm. I run a nonprofit vegetable farm. We're funded by a local real estate developer, and all of the produce gets to go to his affordable and workforce housing units in the Madison area, Mount Horeb, Sun Prairie, Jefferson, too. And so we get to give away all of our vegetables for free, which is fun. And so that kind of informs a little bit about how we did the vegetable or the irrigation planning. Um, when I was a grad student here on campus, this is kind of how I farmed. It was with a ton of people, very low mechanization, very hand labor, kind of like quarter acre, half acre, kind of backyard garden style. So it was the main crop wasn't the vegetables we were growing. It was mainly the like young minds and college students that were kind of working there and building community there. And so that's kind of my background is in that kind of community building with agriculture. But I'm also like a very technical nerd. Like I read like specification manuals, not for fun, but like I like that. I'm not like dismayed by like a chart in the back of like a catalog about irrigation equipment and nozzles. I've been affectionately called a nozzle head. If you are too, welcome. Hello. You're not alone. Um, so I bring this up though, this image because I farmed here for 10 years. I wasn't really that heavily involved in irrigation because I wasn't involved in the source of it. It was just coming from the city. I didn't have any control over pressure and flow. And so I just had to work with what I had. And it was mainly kind of hose end stuff, and just kind of like didn't have kind of end-to-end control over the irrigation. And so I learned a lot here, but I learned a heck of a lot more when I was given this acre to grow by the real estate developer and just said, "Here, you've been growing vegetables at the student farm for 10 years, and other places too. I've worked on commercial farms." And he said, "Here's an acre. It's blank." And I was like, "No, there's a bunch of manure on a horse manure." Um, but no other infrastructure, a couple of T-posts along the kind of north-south uh, line of it, but no other infrastructure. So that kind of really challenged me to build an irrigation system and design an irrigation system with a bunch of help from scratch. And so the point of today, or the way I've structured this today, is not this is how you do an irrigation system in theory. This is what happened to me 3 years ago. Stuff I regret, key successes that like 3 years, 4 years later, I'm like, yes, that was essential that we did that. And then heavy on the mistakes. I'm an instructor here on campus. I'm all about the mistakes as long as nobody gets hurt, and including your pocketbook. So I was given an acre, and so okay, I know enough that I wanted to totally avoid drip irrigation, so I was going all overhead irrigation, and I went, okay, an acre I can do with overhead irrigation. That's fine. Um, and so that's kind of the route I went for this first acre, foreshadowing future years that we didn't just stick with this acre. But I went, okay, we have an acre, we can do overhead. How much do I need pressure and flow again to water an acre? Not all at once, but how do I get that overhead irrigation capacity? Where is that water coming from? Do we need a new well? There is a horse barn on site. So that's the image on the left. I went with my little meter, and was just testing pressure. And I was ecstatic when I found this. I went, ooh, the horse barn has 50 psi. From like my back of the envelope calculations, I was like, I know my end nozzles could function between 20 to 60 psi. I was like, oh, yes, excellent. PSI is in range. You get these little meters. at Home Depot for a couple bucks if you just want to test your hose end pressure. The other math factor, the other factorial when it comes into how much water is flow. So for that, you just take a vessel of known volume, a 5-gallon bucket most people use, and then you just open that valve up as wide as you can and time it how much it fills that 5-gallon bucket or a liter or 10 gallons or 60 gallons, whatever. You do it a couple times, you average it out. Flow was maybe 8 gallons a minute, maybe 12. It kind of fluctuated, not great capacity. I ended up learning that my magic numbers were about 50 GPM, 50 gallons per minute, and about 50 PSI. There was some wiggle room in both of those, but just as the kind of back of the envelope calculation, I was looking for 50 in flow and 50 in pressure. Um, so the horse barn was a no-go. So then so you start calling well companies and who's got wells in the area, what do your neighbors have, um, how much pressure and flow do they have, how deep do they have to go. So that was a lot of just information gathering for me, and it was, yeah, people have not too deep wells, between 80 and 300 feet deep, and they're getting decent pressure and flows out of it. Um, and we wanted to also to stay under 75 because I think that's the cutoff for Wisconsin DNR, like a high capacity well. So, and again, I was given 1 acre, 45,000 square feet ish, and I knew I wanted to do overhead. So I was like, okay, that informs all of my decision making. And then I just kind of like hit a wall, and I was like, this is all what I know how to do. I've engaged vendors before, but I haven't ever designed an irrigation system from source to nozzle before. I was just at the student farm for 10 years. I was given a pressure and flow, and I just had to work with that. So I did engage a irrigation company. They're a materials vendor. But they also do design work. And to my surprise, I was just reaching out to them to say, when I was managing this project, I need supplies. Are you the right people to give me some supplies? And they just, pulled out a sheet of paper and they're like, okay, where's your plot? And just sat down with me for 20, 40 minutes, and just busted out a design. And I just went, oh, what do owe you guys? And they just went, oh, no, no, no. We do this for free. You're going to buy the products from us and the materials and the piping and the nozzles and fittings and clamps and stuff from us. And I just went, oh, great, fantastic. I had no idea that kind of free service existed out there. Um, so great. So this is what the acre looks like from a bird's eye view, on that piece of paper in the middle. And so each kind of circular symbol on the left there, I think I can get a little laser pointer here. Yeah. All right. So each kind of stop sign yield one is a valve. So that's the apparently international symbol for valve. And then your master valve is down here. That's the square with the triangles in there. So that controls all the other sub valves. And then this line going right here is your not quite a main line because it doesn't hold pressure all the time. Again, this is all the stuff that I had no idea about and I just learned along the way. So if you're feeling overwhelmed about irrigation and stuff, every irrigation system is a complete custom job. And so when you move somewhere else, if you try to design something else, it's just going to be new and different. So I'm going to try not to get into too many specifics, but just kind of like general stuff that I learned along the way that I found interesting and useful. So it's not a main line because it doesn't hold pressure all the time because of this master valve upstream here. So it's kind of our main, but in quotation marks, main. And then each lateral here coming off to the right of our valves is a true lateral. It's two valves downstream from the water source, and they're controlled independently. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 laterals. And unfortunately, I inherited this acre, and it's not anywhere close to a square. So ideally, if you can manipulate the land to fit your irrigation system, that is an excellent way of doing things. And I made sure I knew enough about irrigation system design 3, 4 years ago that I knew that this needed to be done right away, that I needed my every other system, crop production system, fertigation system was weeding system was going to be influenced by this irrigation design. So I knew enough to not, just slap it on afterwards and go, oh yeah, I think I can figure out this. No, no, no. It was like day one. Okay, where's this water coming from? How are we distributing it? So downstream of each kind of subvalve is a dot, and so that's a nozzle. And then if you look really, really closely, there's two different colored lines on each lateral. And so that's something I had no idea about was you can change your piping diameter to make sure you have consistent pressure and flow down each lateral. And so the green here between this valve and this nozzle and this nozzle and this nozzle is a larger diameter piping, but as you go further down that lateral, you need to decrease that diameter to keep as constant pressure and flow as possible. Because the main principle here is you're working against consistency. Anytime you pump water through something, it's a dynamic thing. It's going to change over the pipe length, and so you're trying to get the same pressure and flow rate out of nozzle A and nozzle Z down here to get as even of a rainstorm as possible across this acre. And I had no idea that you could change lateral pipe diameter. I, quote unquote, grew up farming just with 3/4 inch black poly pipe, and that was like the only thing we had available to us, and that's what we kind of worked with. And so designing this from scratch, I went, oh, I had no idea. I was like, when they handed me this design, I was like, did you run out of colored um, pencil? Like, why did the change? And they just went, oh, you need to change your pipe diameter to make sure your pressures and flows are constant. I went, oh, fantastic. The other big thing of not having a square or at least a rectangle or the laterals don't have the same number of nozzles on them. That is really frustrating because each lateral is going to have a different flow rate. And so that means my well and my well pump is going to have to act differently when the top zone with 1, 2, 3, 4, 5 nozzles on it is flowing versus not the one right under it only has four. So it's a different pressure and flow. You want to avoid having your well pump go on, off, on, off, on, off. That can just kill the impeller in there. It can lower the lifespan of it. So another design choice that I had no idea about that I learned from these irrigation designers and plumbers was, hey, we can put in a well pump that's capable of 50 GPM and 50 PSI. We just need a VFD, a variable frequency drive on it so that it's not off and on, it's on 10%, it's on 20%, it's on 25%, it's on 35%. It can do different flow rates, not different pressures, just different flow rates based on what zone I'm running here. So these folks are really used to designing golf course irrigation systems and used to designing like big home, like horticultural, like public gardens, but also private gardens on, if you have 3 acres and, several $1 million, you can have your own private horticultural garden and you have these in-ground irrigation systems. So that's what they're really used to. They didn't know what the heck drip tape was. And so I just kind of had to say, I'll figure out that drip tape stuff later. And that's coming later in the presentation when I was handed another 4 acres to do. And after we dug the well, which is really frustrating. But anyways, I got 1 acre. I got a well being dug. Uh, but it was a scheduling thing. They couldn't dig the well until June. The owner really wanted the first production season to happen. Oh, and by the way, feel free to use the chat, throw some questions in there, and I'll be monitoring it on the side. And Anne's already got a note in there. So this is the acre. There's no irrigation infrastructure, but I had to start planting. So I was like, perfect world doesn't exist. Fortunately, it was kind of a rainy spring. So it worked out. We do this weird living aisle system. UW Extension has a little write-up of it about our living aisle system, but that's for another day. Another reason why I wanted to do the overhead irrigation. To water this nice aisle that has many benefits to us. But yeah, you can see no pipes, irrigation stands, no drip, no irrigation infrastructure. We just kind of had to work with what we got. And I was kind of used to that and used to some rain fed, some dry land stuff. And kind of small scale for me. I was just hand dropping potatoes into the ground. Link to that case study on our living aisles and three other farms too across the nation too. So not again growing potatoes on dry land. We're on a silt loam. They probably didn't need irrigation, but if I'm putting in an acre of it on overhead, you might as well. You can see on the left here, there's the bones of a caterpillar tunnel, a small high tunnel or a hothouse built in there. We couldn't skin it. We couldn't put the plastic on it because we didn't have our well yet. So again, just these kind of like layered decisions, almost all being influenced by whether we had good and enough water on the farm. And we were just bootstrapping it. I mean, we had a wheel hoe, and that's how we buried our seed potatoes. Was just me being the tractor and pushing the wheel hoe. So now we're doing half an acre of potatoes with a vibrating digger and a planter, and it takes us about half a day or 2 hours to plant. This took me a long time. Good workout though, really good workout. So pros cons. But no irrigation infrastructure. We didn't even have a shed on site. We're just kind of gardening on an acre, which was in retrospect is absolutely wild to me because now we have standard operating procedures and now it just operates and we're just like, I don't know. Let's just go. So we got a well dug, put a shed right next to it, ran power to the shed. You can see here on the left. Love the electricians that I work with. They really did a nice job powering this shed because the well pump is electric, uh, and so we needed electricity at this shed, 240 volts, and so everything's electric, which is super nice for automating. I'll get into automating later, but it's all electronic, and so that's really easy to much easier to automate, at least from what I knew, than like a gas or a diesel powered well pump motor. So yeah, well casing with a bunch of wires sticking out the bottom, and then some nice electrical coming in. I was also like in the middle of double hernia surgery during this, so just adding to the to the nightmare of project management for this. I was hobbling around the farm, kind of shouldn't have been hopping over these trenches, but I mean this was a super big moment, so I wanted to kind of see it and take some photos and see the progress of it. But we got electricity. So then the plumbers could finally come in and put a manifold on the top of this well because I didn't know enough to get like standpipes for well access, like into the field or hydrants. Like I didn't know enough back then to spec out, okay, I want to trench below the frost line so that we can have like frost-free hydrants like out in the field. And so I knew enough that I was like, told the plumber, I was like, I just need a 2-inch brass valve uh, that I can get my 50 GPM and my 50 PSI out of. And he just went, gotcha. Boom, puts this manifold on. The leftmost fitting here is from the pressure tank, and you can see a nice brass union because you don't want to leave these out over winter. They will frost and you'll be in a world of hurt. So nice brass union so you can take off your pressure tank. And secret to me at the time, you can change the pressure on those with the little bike inflation valve on the top. Cool stuff. I like learning. And then he also added in right here a little hand washing station for us, facing the wrong way, but a pressure valve, a standard hose fitting, which is nice for our kind of makeshift wash pack here. And so we just have hose coming off there for root sprayers, and we could fill a dunk tank and stuff. So really nice manifold here. I had no idea that this was what the plumber was going to install, but I was really happy when I showed up after he was finished and just went, oh, wow, we got a hand washing, we got wash pack here, and then we got the big 2-inch full bore one here. Um, and so that feeds all of our overhead on this 1 acre and will eventually feed 4 acres of drip. And then this piece is this tiny little pocketable piece, the size of like an eyeball, is a pressure transducer, I think, from Denmark. And this thing is like $500 at the time, probably up to like $800 now. So that's just measuring the pressure in this gray manifold, this silver manifold, and then feeding that data through that cable back into our well pump controller or well pump drive in the shed. So then it can kind of maintain a constant pressure regardless of how much demand is there on the system. Because overall, you just need to match the supply and the capacity of your system. Mine was I spec'd out to be 50 GPM, 50 PSI with the like max demand. What's your biggest zone? What's your biggest flow rate? What's the max pressure that you need? That kind of sets your spec for your well, your pump, your well drive. And so just matching that supply and demand is like a really, really big principle in this kind of stuff. So left photo is the kind of bin of stuff that I was used to working with. A lot of hose end, like a Y valve here, like a little pressure regulator, pressure and flow regulator. Um, your like hardware store hose end timer, where you just kind of set the timer on it, and it has some like two AA batteries in the back of it. And that's the kind of stuff I was used to working with at the time. And so I learned about these valves, these kind of black and white valves, and I'll show a photo of those. And that unlocked so much for me. Um, but first, I needed to trench in this quote unquote main line. It's not pressurized all the time, but I flipped this image here in the center just to align. This is the trench that I'm digging here, this pseudo main line. First time I ever operated a trencher, boy, that was a workout. Way too wet. I should have waited for it to dry, but as project management, the things fall apart and you just kind of work with it. So also probably wasn't the best operator of it. And I made the decision to trench this pseudo main line, partially because the people selling me this stuff, that's what they're really used to. And so that's what they recommended. I probably, if I were to do this all over again, I would probably keep everything above ground. It's pros and cons either way. It's a decision you kind of have to make for yourself. Again, everything irrigation is pretty custom. There's principles that are translatable, but like it's really user preference. We went underground. That's what was recommended. Initially, they were recommending trenching all of these laterals, and after way too long trenching this pseudo main line, I just went, I think I'm just gonna put them on the top of the ground and see how that goes. And that's been working great for 4 or 5 years now. So yeah, so weird combo system of this pseudo mainline is above ground, or sorry, below ground. Our valves are buried below ground, and then they kind of pop out on these laterals. So this valve was new to me. This is this a solenoid piston. You can get these for like $12 depending on the diameter and the flow rate that they're capable of doing. But I was used to hose end valves, which are kind of remote. Uh, they don't, the power is from a battery. I didn't know that you could get AC powered valves like this, or you can also get DC powered valves too. So if you don't want to trench in electricity, if that's way too costly for you, your distance is too long, whatever, you can run this whole thing on solar. It takes like a panel the size of like a pizza box that you can just mount on a T-post out in the field, and that can control your controller and all your valves. But you need to make super duper sure whether you're inverting from AC to DC, and all of your valves have to be DC if you're running a solar power, and it's all based on a battery and a DC. So just when you're buying this stuff, just make for darn sure you're getting the one you want. Here we had residential power, so we were running the whole thing on AC power. So all of our valves got AC power. Um, Great. We're connecting them with low voltage sprinkler wire. So it's a thick black cable with this whole rainbow of little cables into it. So if you've ever wired up like a home speaker system, super similar to that. If you've ever done a sprinkler system, it's the same stuff. I just had 13 strand irrigation wire. They sell them in four. It all depends on your initial design, how many zones you need, uh, and how many zones you need depends on how much your pressure and flow is and how much acreage you're trying to cover. So it all kind of like feeds back into itself of how much do you need and matching that supply and demand. So we had, I think, 10 zones total, and so we needed like the lowest amount of sprinkler wire we could run was 13 strands. So we have a couple extras, which is nice. It's kind of wasted buried copper, which is kind of frustrating. But so this is kind of a valve assembly. So this black pipe on the right is what I was trenching in here. So that's our biggest pipe here. And I learned to do two clamps, and these are one ear clamps with a little pincher on it, which is pretty fun. And they're stainless steel, so you can bury them, and they're totally fine. And then just fittings to get us down to this 1 inch diameter valve. And again, diameters here are not really important because it's all based on your design and your demand of pressure and flow kind of influences the entire design here. So if I needed more pressure and flow, I would need a bigger diameter valve here. So we were able to suffice with a 1 inch diameter valve, which is great because they're super cheap. They're very common. Every golf course probably has a million of these. Um, and then you just wire it in, and then this is our lateral line here. So just some fittings in between, and this is actually running our Caterpillar tunnel. So this actually feeds into a drip manifold. So we actually have to filter it and pressure regulate it. More on drip later, though. This is just the nice photo I had. But you're wiring them in a fun way, I think. The person who I bought, or the vendor who I bought all this stuff from, I highly recommend him. Man, it was great. He would come out and this was like pandemic times too, so he would also everything was delayed, and so he would like piecemeal the packages together and then come out and deliver them himself. And I just opened up the box of valves and I just went, can you recommend like a YouTube video on how to wire these things? And he just went, oh, let's just wire one together. And so he taught me how to wire these things and strip this sprinkler wire. So really indebted to that guy. I fond memories. And then also these wire nuts too are the fun ones that are full of silicon goo. So they're for like underground trenching. And so they can get wet, and I've had these things flood and they still work. But make sure you get the like underground ones that are full of goo, as messy as they are. Um, but you wire them together. In a wiring pattern. There's a common wire and a live wire. So that this valve color code is orange. So only this valve gets the orange wire. The white and the red are common, so they're carrying the power to it. The orange wire is carrying the signal. And the signal is coming from a Hunter controller box. These things are like 50, 60, $80 now. And so this isn't my exact model. This only has 8 zones in it. And again, these are super duper common. If you've worked with residential irrigation, you're probably really familiar with this. They have, 60 zone controllers. I needed about 10. Um, and then Yeah. So the really nice thing about these electronic controllers is that you can hook up rain sensors to them, moisture sensors. That's what this SEN business is. So I have a rain sensor and then the white wire here. So you just got to keep track of all your wires. You can wire in. This is your common wire, so that's carrying the low voltage AC to my valves. MV is for master valves, so that's how we did that so that our main line wasn't always pressurized. So then we could spec things a little bit differently and not have as beefy of pipe and expensive as pipe down there. And then if your main line is always pressurized, then what happens when it leaks? You got to dig up the whole thing, and it's really annoying. So the only thing that's pressurized is anything upstream this of this master valve, which is really nice. And then you just have to figure out, okay, master valve turns on, and then half a second later, valve number one turns on, and then zone one is being irrigated. Um, so and all of this. This little module here is a wireless network card. And so uh, when they were trenching in electricity, I was also thinking about data. And so I was sure to get the irrigation controller that had Wi-Fi capability. And so we've actually transitioned to having a wireless router that basically has like a cell phone SIM card in it in our shed. And so it's like a hotspot, but it's powered and it can control traffic a little better than just like your phone being a hotspot or those like little bricks from Verizon, like from like 6 years ago. So we have a little hotspot Wi-Fi that's really just for automation, greenhouse control, and irrigation control. All of our greenhouse is run off one of these controllers too. And because this controller controls all of our valves, all of our irrigation, and it's hooked up to the Wi-Fi, I can control it from my phone. My crew can control it from their phones. We can schedule everything from the phones. We can be out in the field and just pull out a phone and go, hey, let's test valve number nine and not spend 20 minutes walking down to the controller to figure out who miswired the valve or something. You could just be in the field right next to the zone and trigger it on. Um, I personally used Site One irrigation. There's other irrigation suppliers in town. Site One is nationally Siteone. Reinders is another one. Um, they Site One national wide. They do irrigation for a lot of turf grass in professional football stadia. So a little higher stress than my install. But yeah, um, I do not know of any way to recycle drip tape. You can reuse drip tape if you're cautious about it and you're okay patching it. If you are going to reuse drip tape, I'd probably go the 15 mil route. I don't reuse my field drip tape because it's buried under plastic and it'd be a pain to kind of look through it and figure out where all the leaks are. In a high tunnel and a caterpillar tunnel, I'm totally fine reusing drip tape because it's really easy to troubleshoot it. Um, and I think we use 8 mil. That's just the wall thickness of it. I just haven't stomached the cost of a 15 mil roll of it. But yeah, a lot of this kind of stuff, because it kind of overlaps with residential, you can find at Menards and Home Depot, but it's like triple the price of going straight to an irrigation like warehouser. They also have some other fun materials there too, sometimes shovels and fertilizers and stuff. Um, yeah, so we can automate this. Well, we can control it remotely. So we can be at home. None of us live on farm too. This is about a 25-minute drive for me and all of my crew. So we can remotely monitor stuff. We can remotely trigger stuff. We can set up schedules from this, all from an app on our phone. It's super reliable. We've never really had much of a app issue with it, as long as the Wi-Fi is working. And then the other, I think, stunningly beautiful thing about it being on Wi-Fi is that it can access weather data, like super hyper local weather data, and know how much it rained last night. And then it automatically changes based on your settings how much it irrigates that next day. So it can sense, oh, it rained a quarter inch. You're going for an inch of rain tomorrow of irrigation rain. I'm going to drop your time down by the corresponding amount. So it's going to drop it by 25%. And it's going to adjust just automatically to that. And then all of our irrigation happens between like 2 a.m. and 7 a.m. We make sure to have that last zone running as we're all arriving to the farm, so that we just if there's anything to troubleshoot, like that's the downside of automation. When there's a trouble, you don't really see it if it's at 3 a.m. unless you're out in your fields and 3 a.m., which more power to you. Um, yeah, that's the big danger of automation is you're not noticing. Usually, it's harder to notice when things go wrong. Um, and so I added this image. This is my favorite rain gauge ever because it can hold like 8 inches and you get like down to the hundredth. It's like a tube within a tube. It's grotesquely expensive. It's like $45 for a rain gauge. It feels bad, but then you're like, oh, I know it rained 0.67 inches. And then you can kind of truth test your controller here to make sure that it's getting hyper local weather, but like is it getting super high like field specific? So you can make sure like its automation is making sense. Overall, this automation stuff is pretty darn cheap. And it saves a lot of time on our part, and we think we get a yield bump because it just automatically adjusts to the local weather. And it can automatically, we don't spend time walking the fields and triggering irrigation valves and managing our irrigation. It manages most of itself, and then we just kind of step in when we want to and when we need to. I designed it this way. I'm a tech nerd. I like digital electronics. Also, I don't live on the farm. And so I didn't want to drive, 45, 50 minutes round trip to trip an irrigation valve. I wanted to lay in bed and go tick on my phone and it goes, yay, it's irrigating. And I know that. And then once you get on the kind of regular pace of things, then it can just kind of take care of itself essentially. You can also set up programs for like a mist table. So like when we're taking out our transplants from the high tunnel, um, we want to irrigate, like mist them like 8 times a day or something. And so we have a separate mist line and a separate mist valve so that it can kind of just mist itself like really, really frequently. Yeah. Um, what else about automation? I think that's it. So, uh, landmarks here, you got the red shed. Our well is right next to it. And so here's a lateral line. Again, not trenched. We just have it kind of out of the UV by plants. Just the grass is shading it. And then we just have these standpipes. So this is kind of solid set irrigation. Just PVC, just glued it together, super cheap, easy to troubleshoot when something goes wrong. We just have backup standpipes ready to go. They just kind of screw fit in. Nothing sealed except these like fittings. So everybody on the crew is trained to kind of troubleshoot it. So if somebody sees a leak, they can just go back to the shed, grab a new piece, boom, fix it on. 2 minutes later, you're fixed. Um, we went with half-inch irrigation. You can choose kind of between half-inch and three-quarter-inch. We just went for a half-inch, but we got to skin our caterpillar tunnel here because we kind of we finally had water, so we could, put drip in there, and so we could finally put our plastic on. The initial nozzles that were specced out make sense because the designer of it wasn't and isn't a farmer, and they're used to having their stand posts like secured with T-posts and rebar and like really secure. So he specced out the nozzle on top of here. So here you can see there's no nozzle on top of the standpipe. It's just a fountain of water coming out of it. So then the last step is finally after you flush all your pipes and get all the dead bugs and little pebbles and silt out of there, then you can finally put your nozzles on, and they're pricier. They're one of the priciest bits of the whole thing. They're pretty specialized. But we didn't really have our standpipe secured that well. You can see this one's kind of quite at an angle. And that's mainly because these nozzles shoot out kind of like a normal, like gardener, like lawn impact sprinkler that kind of has one nozzle, it's going out. And if you remember from like elementary physics, there's one force, there's an equal and opposite force. So these kind of made the standpipes really wobble because they only had one jet of water coming out of it. So we learned that real quickly because they would just wobble themselves out of their T-post and they would just leak, and it was really frustrating. We spent all this time. So I added this image. These are horrible potatoes. We had bad Colorado potato beetle problems, but not for the potatoes. Don't pay attention to those. Just we changed to the different nozzle here, so we added in wobblers. So we have some wobblers. We also have some that have two jets of water and they're opposing each other, so there's not a wobble force on the standpipe. Super frustrating thing that these nozzles are called wobblers, but they don't make your standpipe wobble. They do the complete opposite because they're spinning and they have this nice like 360 or sorry, 180 degree, no, 360-degree rain pattern. So the forces on that standpipe are even in the whole circle around it, so they don't wobble at all. So it's very gentle. It's very satisfying. It's one of my favorite things to do on the farm is especially when the sun is really low in the sky in here and the angle is really nice. Watch the sprinklers going. Oh, very deeply satisfying. So this is kind of a bit of a summary image. You can kind of see the slit in the earth that we cut and then a buried irrigation valve. And then it kind of this is our pseudo main line. It's not pressurized all the time, but then it kind of pops above ground and then hits our first standpipe here. And they sell a little thing on the top of them called a road guard that turns a 360 nozzle into a 180 so that we're not irrigating like anything beyond the edge of our field. Like if I'm taking this photo, I'm standing on our gravel road. We don't want to water that. That's waste. And it gets everything wet and then weeds grow better on our gravel road. And we don't want that. So we put a little road guard on there. But always going back to pressure and flow, if you turn a 360 sprinkler into a 180, you're going to double your flow going in that radius here. And so we had to size down these nozzles in terms of like liters per hour because they're from Canada, not gallons per minute. And so we had to size these down versus the ones inline, have a certain flow rate. These edge ones have to have half the flow rate because it's 360 becomes a 180. So it's putting double the water on. So fun irrigation math. I hope you find as much joy in it as I do. So let's see. What else do I want to say about this? That's our neighbor spreading fertilizer. So and then I made this system. I was kind of proud of it, and I was like, oh yeah, this is cool. And so each zone kind of runs for a set amount of time, and then it goes on to the next zone. And then mid-season, I was crazy and took a vacation out to coastal California to see my family and see some ag fields. And way out in the distance, you can see the Pacific Ocean. This is near Santa Cruz, and I just was like admiring all the same principles, but just you can see that there's a main line here, like a big thick aluminum pipe, and then they got lateral lines. But each one of these tiny little things is a high pressure nozzle coming out of it. So they have just a huge amount of pressure and flow that they can have all these zones. Like this is one zone. They're all irrigating at this one time. This is probably an 80-acre field of probably broccoli, cauliflower, or Brussels sprouts, and then some fertilizer tanks and stuff. And I was just like, wow. And also, my field doesn't overlook the Pacific Ocean. Shoot, I'm really jealous of their pressure and flow, and also quite a view. It's every day is a good day to be a Brussels sprout over here. It's 55 at night and 68 during the day. It's beautiful. So, but all the same principles of just pressure and flow, and my zones are, 4 to 6 nozzles long. Theirs is like 80 nozzles long. And that's just a zone is just however much you're irrigating at any given time based on your max pressure and flow that you have capable. That's your biggest zone that you can do. So with the last probably 5, 10, 12 minutes or so, drip tape, different than a soaker hose, different than a drip line for like orcharding. Drip tape, very, very common in vegetable systems. I didn't want any of it because I didn't in our first acre because I didn't want to get it getting in the way of cultivation. And so I wanted everything up. And I had the chance of digging a new well. And so I thought, okay, if we can dig it good enough and we can just do overhead, I'm fine with the extra, quote unquote, disease pressure that you get from that. And I felt that was kind of balanced with the automation of it. And oh, it's at 3 a.m. So then the sun comes out and kind of burns off the dew. And there was already dew anyway. So I'm just adding to the dew when it's irrigating at 3 in the morning. And so I thought, okay, my automation can kind of offset the rule of thumb is you never want to overhead irrigate your tomatoes or other, fungus prone vegetables. And then I was like, ah, crap. We put on a caterpillar tunnel. We need some drip. So I needed to buff up on my drip tape knowledge. So there's an emitter at the center of these. I think this is a 12-inch spacing. So there's just a little emitter like welded into this drip tape. And so that drips at a set rate. Really important when you're buying drip tape is to get pressure compensating or PC drip tape so that if you have a 500-foot line, nozzle number one over here is dripping at the same flow rate as nozzle 500 way on the other side of the line because your pressure and flow are going to be different at different lengths in the pipe. And so you want a pressure compensating uh, nozzle or drip tape so that each one emits the same rate. So you have, again, really even rainfall and rain spread and water across the entire like XY axis of your field. So I only messed with drip as much as I needed to the first year, and it was really just running into a caterpillar tunnel. And then we kind of we were quote unquote too successful, and the owner said, "Hey, you were great on 1 acre. Here's 5 more." And I just went, "Oh, great. Thank you. Appreciate it so much." But also we did all of our irrigation design based on overheading 1 acre. Now I'm in the situation that probably many of you have been in the situation of I have a well, I need to match my system to that existing well. And so I went, okay, I think I can do it. And so I did some back of the envelope calculations, and it's like also that 4 acres is 600 pipe feet away and 25 feet up in elevation. I went, oh no, we're starting with 50 GPM and 50 PSI, but we're going 600 pipe feet and we're going up in elevation. All those things are leading to lower pressure and flow. Long story short, the left image is the first time I got water up into the corner of this field out of this lay flat. And really dull photo for 99.9% of the entire world's population. You all probably get the joy of like, haha, I've made water travel out of a 250-foot deep well, through all this piping, through all this automated valves, through this lay flat now that's 600 feet away from our 1 acre field into this 4 acre field. La-di-da, I've made water flow. First hurdle passed. What pressure and flow do I have was my biggest one. You can roughly calculate it. There's plumbing calculators online of if you have a 600-foot pipe that gains this much elevation, how much pressure and flow and friction loss are you going to have? So I roughly calculated and I went, I think we can do 4 acre irrigation on drip if we get the right everything for it. So this green pipe feeds into the right side. You can kind of see the green pipe on the ground here. So eventually it feeds into the right side of this filter assembly here. Again, more terminology of the plumbing world. Filter assembly. And so things to note on this: pressure in is matching pressure out. Ooh, victory. There's no significant pressure lost based on the filtration, so it's not filtering too fine that we're losing pressure. And the pressure isn't being lost because the filter is clogged. So really nice, like anytime we drive past this or walk past this and it's irrigating, we double check, okay, when do we need to clog the, or when do we need to unclog this filter? It's just a mesh filter in here. And so we know, okay, about once a week, pressure drops significantly on the out that we need to back flush this filter and unscrew it and clean it out. Uh, Other thing to know, anytime you need to filter drip tape because any sort of little bitty sediment that can get in there can clog a dripper and totally mess you up. So you need to filter it. How deeply do you need to filter it? That's based on your drip tape specifications. So again, you're looking in the technical like references of these drip tape things of okay, what micron filter do I need? The big trouble is some companies use micron, which is like the size between the filter, like fibers. Like there's 80 microns here. Some use mesh. Mesh is just another unit of measuring how tightly the mesh is like pushed together. And so really double check that you're getting the right mesh size or the right micron size in a filter. And they're really annoying because like they're kind of close, but kind of inverse. Like as micron goes down, mesh size goes up. And so I think this is 80 micron, but it's like 150 mesh. And just look up the table, make sure you get it really, really right. The other thing when you're doing drip to really consider is filtration, or sorry, filtration, but also pressure and flow. So there's a pressure and flow regulator here right on the left. So apologies for the really messy photo. And it's this is our filter assembly again. In this hookup, it's the water is actually coming in from the left. We put unions in so then we could take it off and service it really easily. So you didn't have to like unscrew the whole thing. We also have a water gap here that the water is coming in here and closing. There's a little ball float valve in there, just so that there's somewhere for the air to escape out of the system and not through our fittings and through our drip tape, because you can pop off your drip tape fitting. So there's somewhere for the air to escape so the air doesn't kind of build up and hyper pressurize the system. So that's a neat little trick that you put kind of right before your filter assembly so that it kind of water flows out and then closes that little valve. So, but there's somewhere for the water to go. We also put a upstream valve, and eventually, down here we put a downstream valve so we can kind of isolate the filter so the system can be running, but we can turn off the upstream and the downstream valve and kind of open up the filter and clean it out. And then we spec'd out this is a pressure and flow regulator. So we needed to match the flow of this to the kind of total zone flow that we needed on our drip tape zone, the 4 acres of drip. And then we also needed to match it to the max pressure that you can run drip tape on. We had 40 psi coming in here. If you know anything about drip tape, that's like way too high. So we're dropping it down to 15 psi. It's kind of labeled on the other side of the thing. But again, pressure and flow always interrelated and always need to regulate and be aware of them. So this is kind of how this field looks like. Out of this end of this pipe and this filter assembly comes this big 4-inch diameter white pipe. And then there's just a little L fitting, and then that's our drip tape going in and underneath this bioplastic, biodegradable plastic that I absolutely love and wish was organic certified, but it's not yet in this country. But it's kind of buried. And so that's why we don't reuse it, because mice can dig on this and chew little holes. Your crew can put little holes. I put holes in it. Twigs touch it. It's just kind of not that reusable. And then it's a giant headache when you spool this back up and then kind of bury it. And then you're like, where do I hear that water flow coming from? So we do use fresh drip tape here every year because it's such a management pain if we get or when we get leaks in here. So we really want to minimize the leaks. But this is like really water conservation, really slow flow. It's all automated and it's underneath this plastic. So it kind of hydrates just the rooting zone and not the aisles. And this is a photo from that giant drought year we had with all the smog and the fire smoke from the forest fires in Canada. So this is the best squash patch I've had in 17 years of growing because we controlled all the water and there were no weeds in the aisles because it didn't rain for like 8, 9 weeks in a row. And so we had just so many squash out of here and they were just so happy. It was like growing in Central Valley of California. It was amazing. It was horrible for everybody else who didn't have such control over water. So I'm not saying it was the best year, but really good for us. Last thing I want to end on was a big thing that I discovered with drip. Whenever you look at a spec sheet on drip, there's tons of these things. There's like 8 of these tables. There's like dripper flow and emitter flow. The big thing that I found is this Q100 number. And so what I find really nice about the Q100 is that it's not the flow rate of each nozzle or each dripper emitter, it's the flow of 100 feet of drip. And so that makes all the math easier because I don't know how many drippers I have in my field of 4 acres on drip, but I know exactly how many linear feet of drip tape I have. So then I know I have green dripper color, or sorry, blue dripper color. We're running at about 10 psi with all the pressure drops and stuff. Our dripper spacing is 12 inches. Boom, I have my exact 0.22 GPM per 100 foot. I can multiply that by however many 100 feet I have out in the field. I know my total flow rate. That's my zone size for my drip field. Because again, your zone, you're just matching your zone with your supply capacity. And so, because drip is knowing how much to water with drip is annoying, and knowing how much drip you have is kind of frustrating, and then calculating it based on dripper size. So I really found a lot of peace in my math mind of this Q100 of how much flow do you have across 100 feet rather than trying to mess with the calculations of each dripper because you might have 8 inch drippers, you might have 12-inch dripper spacing on the same farm, and then your math totally messes up. But if you're doing Q100, it's kind of even. So I fell in love with Q100 when I found it, and was just like, this makes the math so nice. I have, 6,000 feet of drip. I know exactly how much flow is going through those drippers on that 6,000 feet. And can I do all of my 4 acres in drip? It's all based on this sort of calculation. Or do I need two zones of drip because I have 50 GPM? What is this number, into however many hundreds of feet I have of drip? So, not the, to me, it's really exciting. Not the most exciting thing to most people, but I gather I'm in good company of some fellow nozzle heads. So feel free to, we have a couple minutes left. That's the end of my presentation. I'm ending on a really dull table, but I think it was really exciting when I found this Q100. It made all the math kind of make sense in my brain. So. Um, Again, irrigation is all custom. I wish you all the best in your irrigation journeys. And they're all individual journeys, but I'm always here to commiserate with you about the pains and the successes. And I hope you've learned through some mostly from my mistakes, because there's certainly more mistakes than things that worked well here. So feel free to, raise your hand, put stuff in the chat. And do you have something to say?
Yeah, first of all, thank you, Tom. That was awesome. Tons and tons of information. I even took a few notes down, so I appreciate it. Yeah, if anybody has any questions here, this is still going to be recorded, so if you have to hop off, you can listen to the questions later. I am going to throw up a quick little poll because we are a lot of our funding comes from federal sources. We are required to report on our demographics on who we are serving and to make sure we are reaching parity with the census. And so it's anonymous. It's only going to be up for a couple of minutes. Please, this helps us with our reporting. So I appreciate if anybody can fill it out, and Tom can answer any questions for you as he's wrapping things up. Feel free to just pop off of mute or put it into the chat. I think everyone's just kind of dumbfounded at all of the amazing information. We'll be sending this out, the recording out to everyone who registered in the next couple of days. And maybe if Tom's got some resources he can share as well, I can add those to the email that I send out.
Hi, and my the survey has disappeared from my screen. Thank you. Hello.
Hey, Tawanga, do you have a question?
No, I was doing, there was a survey that came on the screen. It popped up and just disappeared, like the demographic thing.
Oh, yeah, yeah.
It's gone.
Yep, I stopped it just so it's not in front of everybody's face any longer.
Oh, okay.
Well, looks like we're good to go here, Tom.
Cool. Thanks, everybody, for your time and attention. Good luck plumbing out there.